Hello, I'm going to talk about normal distributions and z-scores, how to use the standard normal table to find z-scores. I want you to understand that the z-score corresponds to the number of standard deviations that a value is lying to the right or left of the mean. The bell curve is pictured here, and we'll talk a little bit about those percentages in a minute. The standard normal table is going to give us the area to the left of the z-score that we come up with. So here's a problem. We have a survey taken. You got a group of men in the age ranges of 20 to 29. We're given that the sample is normally distributed and that the mean of the sample is 67.8 inches and there's a standard deviation of 3 inches. Study participant is randomly picked, and we want to know what is the probability that his height is less than 65 inches. So first of all, you need to write down what you know. You have to know the mean, 67.8. You have to know the standard deviation, mu and sigma. Standard deviation is 3. Now to solve it, we have a nice formula that I want you to write down in your notes right now. And that formula is z equals x minus mu divided by sigma. X in our case is 65. That's the height that we are focusing on. Mu we are given is 67.8 and sigma is 3. So we just do the little calculation. 65 minus 67.8 divided by 3 will be negative 0.9333. Now that's the z-score. And you're going to go now to the standard normal table. The standard normal table gives you the z-scores in the left column to 2 significant digits. And then if you were looking at 3 significant digits, 933 would be 3 significant digits, you're going to have to move across the table, in this case to the 0.03 column. So fix in your mind now that we're looking at negative 0.93. You can do a little process called interpolation because, of course, there is a column next to that, which would be 0.04. And it turns out, of course, that the value we're looking for is in between 0.03 and 0.04. For our purposes, when you're reading from the table, I'm going to suggest that you'll be wisest if you don't try to do any interpolating, coming up with a closer value. Just decide which of the z-scores, negative 0.93, is closer to the value you're looking for. In other words, the next one would be negative 0.94. And you can see by looking at the 9333 that we're closer to 0.93. So we're going to use that value, which is 0.17619. Now that number, 0.17619, simply tells us that this percentage of the area under the bell curve and the data values that are in our sample are going to lie to the left of this point. So only 17.6% of the heights in this sample we would expect to be less than 65. All right, let's look at the next problem. What I'm going to do is show you how to solve using Excel. Given the same information and the same probability that we're looking for, we have a function, a formula in Excel called norm.dist. It's very similar to the ones you used last week. And this one requires 4 arguments. The first expected argument is the x value that we're trying to find the probability for. That would be 65. Mu is next, which is 67.8. Sigma is third, which is 3. And then true or false. Do we want the value probability of x equals 65? If so, we would say false. If we want the probability of x less than 65, that means we want to sum everything in front of it. So we're going to say true. And we come up with a number that's pretty close to the one we had on the preceding slide. Notice that there is going to be a slight difference in values. Usually, I think for the problems, you're probably asked for 2 decimal places, hopefully, in most of them, because Excel and the formula that you've used are usually going to be the same too, 2 decimal places. The reason that there's a difference, by the way, is that Excel is actually doing that interpolation. It's recognizing that the value we're looking for is actually in between 0.93 and 0.94, and it's going to actually move a little bit to the right and come up with a slightly different value. Okay, but let's not worry about that. Okay, here's the next problem. And this should be familiar from what we've already done with discrete probabilities. Let's find out what is the probability that this randomly selected person has a height between 2 values, 65 and 72. We've got the same given information. We've already calculated the probability of x less than 65. So the area to the left of 65 we know is 0.1762. Now, we're going to look at 73. Why did I do 73 here? Um, hmm. um, because we want 72 to be included. So that's why I did 73. So we're finding the z-score for 73. So we know that the area to the left of 73 is going to be 0.95818. And the reason we know that is that the z-score when we plug into our formula is 1.733. So now we go to the standard normal table and we look for the positive columns on z, and we find 1.7 up there. And then we move across to 3. So 1.73 is 0.95818. And once again, our actual value is going to be a little bit to the right of that. So when we use Excel, we're going to get a slightly different number. So the probability that x is less than 73 would be 0.95818. And therefore, the probability that this person's height is in between those two is simply the difference. 0.958 minus 0.176, or 0.782. I've given you the URL here for a very nice PDF copy of the table. I suggest that you download that and print a copy. Keep it in your notebook, and because you're going to use it a lot. I think there is one in the appendix for your ebook, but it'll be a whole lot easier if you have it in front of you for quick reference. Okay, now let's talk a little bit about that bell curve and the empirical rule. The empirical rule simply says if you're given a set of continuous data and you're told that it's a normal distribution, then we can expect that 68% of the data is going to lie in this yellow region right here. 68% of the data is going to be in here. We can expect that 95% will be in this slightly larger region, and that 99.7% will be in this very large region. Now, the numbers at the bottom stand for standard deviations from the mean. So 0 is the mean, and notice I've labeled that 67.8, which is the mean for our example. The -1 value says at this point, you are 1 standard deviation to the left of the mean. So we need to subtract 3, and the -1 point then on the bell curve for our example would be 64.8. The +1 on the other side says you are 1 standard deviation to the right of the mean. So we're going to add 3 and get 70.8. And then I moved ahead to the 2, which of course would be 2 standard deviations to the right of the mean. So we'll add another 3 and we get 73.8. Now let's look at our problem. We came up with a value, a probability of 78.2%. So the empirical rule says that between -1 and +1, between 64.8 and 70.8, we should expect 68% of the data. Well, the 64.8 is pretty close to our lower limit here, but our upper limit is 73, right? So our upper limit is almost 2 standard deviations to the right. So we've got this little pink area here. If we did a little quick subtraction, let's see, what is that, 27%? So we'd have to split it. So it's like 13.5% of the actual data is sitting in this little pink region here to the right. So we came up with 78.2. So if we take 68 and add 13 to that, what are we at? We're at 82%. So our 78.2% is a very reasonable result here. Okay, I hope that's helpful. Um, Students typically have a lot of trouble making the connection between the X value, the value we're looking for the probability of, and the Z-score, and what you're getting out of the table, which is an area to the left of that point. Okay, so try to fix that in your brain here, and hopefully after you work through a few problems, it will become very clear.